ke nna o la ke buile hape bjanong ka translation ne a ke re ko previous lesson ne re etsa transcription bjanong re buile hape mRNA strand se se formilweng from DNA sa tswa bjanong through nuclear pause ne a re separate taba tsa rena ne I'm gonna separate taba tsa rena ka mo ke ka mo ke ka mo nucleus through the nuclear plasm in the nuclear plasm. So the nucleus in a pause. Ne? Those are nuclear pause. So all of each mRNA it's via the nuclear pause. Yeah, it's like a cytoplasm. Cytoplasm. Kamo cytoplasm re tlo perform a translation. Then re tshwere di-plan tsa di-AMG re fitla ka mo cytoplasm ne where in the cytoplasm ka mo ara ribosome ke ko Mercedes-Benz re plan ya shi mRNA ya rona a re tsieng re draw ya pape mo mRNA ya rena so mRNA ya rena a shi ya fihla kopelo le lebelisa godimo gore ke khonele taba tsa ka simple re na le U re na le A re na le U that's codon number 1 codon number 2 re na le C re na le G re na le GM codon number 3 remember ke example ne re na le C re na le A re na le U a shibane e fihlile e keng ke mRNA ke di plan tsa re ne good now mRNA it's a code for protein but re ka se etse AMG e re sena di parts ne re sena di parts bjao ke mo tRNA e tlo tsenang ka di anticodon tsa yona bjana so we let's look at what happens we will have remember we are in the ribosome na bjana ronna le tRNA tRNA itla ka what we call an anticodon so that's a complementary triplet base triplet to the mRNA codon ne ya tla ka yona tRNA shi ya ntla ya fitla mo scenario e fitla e kra re codon e ke UAU so what will complement it U e phera leng e tlo phera le A e tlo re A e fetse be e re A parallel U and then a very A. King ke tRNA yantle. But tRNA I baili one. tRNA e tla itshwereng. E tla itshwere for example. Amino acid X. Tloela go dimo ke amino acid X. Ash. Remember tRNA yona e tla deliver fair. Mmere kwa yona go deliver. Then tRNA ya bobedi ye tla shile bjana ne tRNA ya bobedi ye tla ka eng another anticodon on the second codon yo anticodon ya thinking ke G ebe na C so that is an anticodon ya eng ya tRNA ile yona ha itle fela e tla itshwere amino acid Y. These two they form a peptide bond. Ne? Now they form a peptide bond. Ne? After this then tRNA yantla ya tsamaya. Ne? Akere di bondi. Then rako ntwenye. Rako let's use a different color. Yes. Rako tRNA transfer RNA ya bus 3 ye tla it's very anticodon a complementing this codon ya mRNA ya rena so yo ba G ya ba U ya ba A so it's GUA ne that is there. Remember this is for example purposes obviously It's longer than this, ne? Ashile e tle bana. I tli one tRNA e tla tshwereng amino acid Z. Amino acid Z le yona e pitla e forma a peptide bond. Ne? Then what happens? tRNA ya rona ya tsamaya. Ne? And then ka re feditse ho build a polypeptide ya rena le tRNA ya tsamaya. What are we left with? We are now left with this polypeptide. The protein in re batla re feditse. This is our protein. Ne? So protein ya rena e consists of amino acid X, amino acid Y, and amino acid Z. This is our protein. The form again. The bond ka a peptide bond. So basically that's what happens. Summarize it. Good. So basically we are learning during translation. Transfer RNA in the cytoplasm has 3 adjacent nitrogenous bases. Adjacent to what? To mRNA. Redivitsang di anti-codon. mRNA codons dio complementary to tRNA anti-codons. And then tRNA, transfer RNA, ke tsona tsa tla ka di-parts wa itse. A di tlile one. So we are e tla ka di-transfer, e tla ka di-amino acids. The amino acids, ne? Good. Dia bond. Ne? Dia bond. E di bonda ka peptide bond, di forma protein. So basically ke yona our protein synthesis, ke translation e. So basically ke yona tabe e irahala. Wa bona transfer RNA di tla ka di-parts video, ne? Di tla ka di-parts and then re feditse, ne? A re bontsha pa. Wa bona transfer RNA ko dimo kwa mo ko ona mo ileng keng ke polypeptide ya re. Wa bona? And then once you transfer wa tsamaya. Let's look at it again. Once you transfer taba wa tsamaya, o transfer taba wa tsamaya. Ke conveyor belt wa tsamaya. Wa bona? Good. Wa bona? Ashile transfer RNA. This is another one that's nice. Yetla shile a peptide bond is formed and then ola wa tsamaya. O mongwe wa bobedi o etle. Shule peptide bond o shile amino acid. So let's look at it again. Peptide bond wa vai. Another transfer RNA etla ka amino acid ya yona. Peptide bond ya vai. Good. So that's basically what really happens during translation. Now, as this happens, hence this copying irahal, deposit irahal, we know nothing can ever be perfect due to different carcinogens, for example, or not carcinogens, things that can cause mutations in your genes. What is your genes? Your DNA. So mutations can occur. What are mutations? The mutation is the change, the alteration in your genetic code. For example, when ka raka, RNA since re itse hore amino acid X, Y, and Z e forma ke mRNA based triplets tse di-codons, and di-codons tse di tlhako DNA. DNA ne leng re boele mora DNA rona ne le ATA GCC GTA. If for example re ka change sequence ya our DNA, sequence ya DNA ya rena re change e tlo change amino acid re ka change e tlo change let me start again. Sequence ya di base triplet e ka change go DNA e tlo change sequence ya di codon tsa mRNA. Sequence ya di-codon tsa mRNA e ka change due to a mutation. It will change the type of amino acid that comes. Therefore, ultimately the same protein. Rerabia. For example, let's use a different one. Renali DNA T A, and then A T G, and then C C C. Ne? Good. Here translate this is DNA. Here transcribe. If we transcribe this DNA into mRNA, it over A T it over A T yaba A, and then A yaba U. Ne? Then rabaleng U, rabaleng A, and then C, rabaleng G, G, G. Ne? Then what will the transfer RNA anticodon be? Anticodon e tlo tla e le bjang? E tlo reng? U A. E be reng? A U G. Ya mafello tlo ba C C C. This is our anticodons. Ne? They three. Good. Even now, the last part. Really, A coder for amino acid X, A amino acid Y, A amino acid Z. Now, are changing them. Let's say a mutation is alteration. Ne? Alteration. So let's say you know change. Arasana A mo. A yela ya change Eva T. Notice that this one leon it will change. Ne? The first codon it will change. Yoba A. We have triple A now. Then the anticodon leon it will change. Yarefang U. Ne? Yarefa U. Triple U, this anticodon triple U, yona a coder. Let's say for example, a coder for amino acid P. Now, our initial polypeptide engineering protein build amino acid X, Y, Z. Now our amino acid actually X, Y, Z. Kini ki P, Y, Z. Now arsana amino acid arsana protein ela le sulfates. Now ar shebeng bjano re can say detail. Arshebe. Mutation di change kae? First change e occur go DNA, ne? And then this leads to a change in codon tsa mRNA ya hao. Then into anticodons tse di tlisang. Anticodon e change a different amino acid, ne? Into the ribosome. Then a change in sequence ya the amino acid then leads to the formation ya a different protein. But the same amino acid ne e kono tlisa ke e kono ira ke di anticodon tse di, so that will not lead to any change. So if Bob would question more examine, you must be very specific. Kuro change it, A change it yaba T for example go DNA. Then ya khosa hore go mRNA arsana for example urinally A for example. So you must be very specific. Be very specific. You can't just give the answer fair. So over specific, we change it gwa tšhentšha o tšhentšitse base triplet ya DNA. Base triplet ya DNA o re botsa gore ke efe, and then if e tšhentšitse codon efe ko mRNA o re botsa gore ke efe, ne? And then if amino acid e tšhentšitse due to change ya anticodon o re botsa gore amino acid e tšhentšitse from here to here, then ko mafelo tla re botsa gore protein ya e sa le yona ele, ne? Great. That concludes our lesson, I think, on